Since a few classes we were discussing about the second unit called vectors. In the last class we discussed about multiplication of vectors. In that we were finished the dot product. What is dot product? How we can use that dot product in finding the properties of dot product, that is cosine of angle between the vectors, a vector projecting on another vector, and application of vector, that is work done. We were discussed all those things we have discussed in the last class. In this class we shall discuss about the another type of multiplication of vector, that is cross product, or it is called vector product. Here when we multiply two vectors we always getting another vector, so therefore it is called as vector product, and it will be denoted by using the multiplication symbol cross. Hence it is the cross product. After multiplication of two vectors we get another vector. Suppose A and B are vectors. Their vector product is denoted by A cross B. Their vector product of A and B is denoted by vector A cross vector B. Hence it is said to be cross product, right? Let us take the definition of cross product. It is similar to dot product. Suppose A and B are two vectors. A and B are two vectors acting at a point C, like this. This is a vector A and this is a vector B. In between these two vectors there is an angle theta. What is theta? Theta is angle between the vectors acting at a point at an angle of theta. Then A dot B is defined as A cross B is defined as magnitude of A, magnitude of B into sine theta. Magnitude of A, magnitude of B into sine theta. So the resultant is always a vector. The cross product resultant is always a vector. According to the rule, there will be a unit vector along the vectors. There will be a unit vector along A cross B. So I will take n will be the unit vector along vector A cross B. See where n is what? N is unit vector along or in the direction of A cross B. The rule says that every vector is always associated with a unit vector along it. So that is n here. Or if I take magnitude of A cross B, that is equal to magnitude of A, magnitude of B into sine theta. So n becomes what? So unit vector, what is its magnitude? Its magnitude is equal to 1. Therefore, finally, we have magnitude of A cross B. Magnitude of A cross B is always be equal to magnitude A, magnitude B into sine theta, right? This will be the definition of cross product. Right? We have a properties for this. Properties of vector product. The cross product is a vector, right? Cross product of two vectors is always a vector that will be always perpendicular to the both vector A and vector B. The first property says that A cross B is a vector always perpendicular to both A and B. Perpendicular to both A and B. The second property, magnitude of A cross B is always equal to magnitude of B cross A. But A cross B is not at all be equal to B cross A. But we can have the equal. When we say equal, A cross B is equal to minus of B cross A. A cross B is always equal to minus of B cross A. A cross B is not equal to B cross A, but magnitude of A cross B is equal to magnitude of B cross A. The other properties, I is unit vector along x-axis, cross J is unit vector along y-axis. Their cross product is always be equal to I cross I. If I take same type of unit vectors, I cross I, J cross J, K cross K, which are acting in the same direction, correct? This is x-axis, unit vector is I. This is y-axis, unit vector is J. This is z-axis, unit vector is K. If I take two unit vectors I and I, they will be in the same direction, I into I. Both are in the same direction. What will be the angle? So angle is equal to what? Angle is equal to 0. What is sine 0? Sine 0 is 0. Hence, A cross B, according to this rule, A cross B is what? Magnitude A, magnitude B into sin theta into unit vector. If this is equal to 0, then it becomes what? 0. A cross B is equal to 0. It means that any vectors, if they are acting in the same direction, their cross product will become 0. Here, I cross I is equal to 0. Similarly, J cross J is equal to 0 and K cross K is also 0. I cross I, J cross J, K cross K, which is always be equal to 0. Next point, if I take perpendicular unit vectors I into J or J into K or K into I cross J is always equal to K. J cross K is always equal to I. K cross I is always equal to J. This is very important. Next point. So as I mentioned earlier, A cross B is always equal to minus of B cross A, right? So according to that, J cross I, if I take J cross I, that is always equal to minus K. K cross J is always equal to minus I, and I cross K is always equal to minus J. These are the cross product of unit vectors acting along x-axis, y-axis and z-axis. Their cross product is given in brief. Okay. Let us take two vectors A, that is equal to A1I plus A2J plus A3K, and B is equal to B1I plus B2J plus B3K, which are the two different vectors. Their cross product. How to find out cross product? That is an important issue. So if I multiply these two, A cross B is equal to A1I plus A2J plus A3K into B. What is B? B1I plus B2J plus B3K. How to multiply it? This, it is an algebraic operation. A1I is to be multiplied with B1I. So A1I is multiplied with B1, A1I is multiplied with B2J, A1 is multiplied with B3K. Right? So what we will get? A1 into B1 into I cross I plus A1 into B2 into I cross J plus A1I is multiplied with B3K, that is A1 B3 into I cross K, plus in the similar way you multiply B2J with B1I, B2J with A2J with B2J, A2J with B3K. So we will get like this: A2 into B1 into J cross I, J cross I, J cross I plus A2 is multiplied with this term, A2 into B2, J cross what? J plus A2 into B3 into what? J cross K plus the third term is multiplied with all the three terms in the next bracket. That is A3 into B1 into what? K cross I. It is simple multiplication. Plus A3 into B2 into K cross J plus A3 into B3, which are the unit vectors K cross K. This is multiplication, right? Next, using these properties, just simplify it. I cross I 0, J cross J 0, K cross K 0. That means this becomes 0. I cross I is 0, 0 and everything is 0. Similarly, J cross J is 0, K cross K is also 0. Three terms vanished. Okay. Next, A1 B2 I cross J. What is I cross J? It is K only. That is A1 B2 into K plus A1 B3 I cross K. I cross K is equal to what? Minus I cross K is equal to minus J plus A2 B1 J cross I. What is J cross I? J cross I is equal to minus K plus A2 B3 into J cross K. What is J cross K? It is equal to I plus of A3 B1 into K cross I. What is K cross I? K cross I is equal to J plus A3 B2 into K cross J. K cross J is equal to minus I. So if I simplify it, A1I, A2. See the common terms K. This is K. Okay. Here we have K. Here we have a K. Next, here we have J term. Here we have J term. Right? This is I. There are two I terms. I am taking this in this form. I into. I am taking I common. So I into A2 B3 minus of. Plus into minus is minus of A. Okay. Next, I'm taking J terms. Which are J term? This is J term, and which one is other one? These two. Here I'm taking minus J common. If I take minus J common, what it happens? A1 B3. Here is plus. No, this will become minus. A3 B1. Next, here K terms. I'm taking plus K common. Plus K common. A1 B2 minus of. Plus into minus minus. A2 B1. A2 B1. Finally, this equation can be taken in the determinant form because it is appearing as an expansion of determinant. So like this, A cross B is equal to I J K is what? First row, I minus J plus K. It is an expansion, no? Next, second row. Second row is always constants of vector A. That is A1, A2, A3. Third row is always constants in the vector B. B1, B2, B3. This is called A cross B. Please, this is an information I've given you. Don't remember all those things. You just remember it as a formula. That is A cross B can be found using this determinant form. I, J, K is first row. We have taken A cross B. In that case, A vector constants are A1, A2, A3, which are taken as a second row. Second vector is what? B, whose constants are B1, B2, B3. You take consequently the constants in this vector as second row, constants in this vector as third row. This will be the cross product formula. Okay. After expansion of this, you are always getting some constant into I plus some constant into J plus some constant into K. This will be the end answer or resultant of A cross B. Just remember this formula. A cross B is what? IJK first row, A1, A2, A3, constants of first vector, B1, B2, B3, third row, constants of second vector. Right? So we can also get magnitude of cross product. Magnitude of cross product. That is from the above derivation. Assume that this will be the end answer of cross product of A and B. So to get magnitude, as we know that constants of IJK, coefficients of IJK should be squared and added. X square plus Y square plus Z square. This is the way in which we can find out A cross B as well as magnitude of A cross B. Next property, sine of angle between the vectors. Sine of angle between the vectors. So as we know the formula, what is that? Magnitude of A cross B is equal to, I mentioned it earlier, A cross B is what? Magnitude of A, magnitude of B into sin theta. Is it right? With this, we can write formula for sine of angle. Sin theta, that is sine of angle. Sine of angle is equal to what? Sin theta is equal to A cross B, its magnitude, divided by magnitude of A, magnitude of B. Sin theta is what? Magnitude of A cross B divided by magnitude A, magnitude B, which is derived from this formula. Next property, we can get a unit vector along or perpendicular to the both A and B. That will be along A cross B, right? Unit vector perpendicular to both A and B. As I mentioned earlier, whatever the vector we get after multiplying A and B, that is A cross B is a vector. A cross B is a vector which is always perpendicular to both vectors A and vector B. That we need to find out. So unit vector is always vector A cross B divided by whose magnitude. Please remember this one. Unit vector of A is always equal to vector A divided by its magnitude, correct? We are finding a unit vector along A cross B. That vector is always perpendicular to both A as well as B vector. That's why we are taking unit vector is nothing but vector A cross B divided by its magnitude. Area of a triangle, area of a triangle having its sides A and B. See, this is a triangle. This is vector A, this is vector B. If I know any two sides of a triangle, with this I can write the area of the triangle. So area of the triangle is given by half into magnitude of A cross B. This area of triangle having the two sides A and B. Suppose if I know A and C, what is formula? Half of A cross C. So if I know B and C, then which formula I used to take? Half of B cross C. So if you know any two sides of a triangle, with that you can write the area of the triangle as half of magnitude of cross product of those two sides. Area of parallelogram. Area of parallelogram having the adjacent sides. Having the adjacent sides A and B. Suppose in a parallelogram, if I know the adjacent sides of a parallelogram A and B. So with this I can write its area. So area of parallelogram is always equal to magnitude of A cross B. For a triangle, it is half of magnitude of A cross B. So what are AB? A and B are the two sides. In case of parallelogram, it is only magnitude of A cross B. What are A and B? Which are the two adjacent sides of a parallelogram. We have application of cross product. Next property or application of cross product. application is movement of a force. For dot product, what is application? Work done by a force. Assume that I want to define what is movement first. Movement is nothing but, observe this, we have an object fixed at a particular point. So this is the fixed point, and this will be the axis of rotation. So if I give a force at other end of the object, it starts rotating, right? Either it can rotate in clockwise direction or it can travel in rotate in anti-clockwise direction, right? So this rotation or turning is because of that force, right? This effect is called as moment of a force. The turning effect of force is known as moment of a force. Okay. See this. This is an object. I am fixed at a particular point, and I used to apply a force here. This is the application of a force. What happens? The body starts rotating in this direction. Rotates. Suppose if the force is acting in this direction, the body will be rotating in this direction. Okay. Take this point as A and this point as B. What is A? A is called force acting point. What is A? A is force acting point. Force acting point. B. What is B? B is moment about point. Is always mentioned like that only. There will be 2 points. One is moment about point and other one is force acting point. You consider force acting point is always A and moment about point is always B. Get their position vectors. What is position vector of A? OA. What is position vector of B? OB. Then the distance between these two will be always considered as R, S, D. It is conventional. You can take anything. So here I am taking as R. It will be called arm length. Okay. So R is always equal to AB. So how to get R? It is OB minus OA. Position vector of the terminal point minus position vector of initial point. OB minus OA. In some books, it is mentioned that R is equal to AP. P will be the about point. A will be the force acting point. So you follow any one convention, right? So I got R. Therefore, moment is equal to F cross R. F cross R. What is R? It is AB. It is AB. Suppose if I take R as BA, then this will become what? OA minus OB. In that case, moment will be R cross F. So you take it seriously, the about point and force acting point. So if take from A to B, force acting point to about point, this will be the formula. Moment is equal to F cross R. Suppose if I take BA is R, from B is initial, A is end. If I take BA is equal to R, in that case, moment become R cross F. Okay. Finally, moment magnitude of moment become magnitude of moment is equal to, so we will be getting a vector at the end of cross product of F and R. Their magnitude can be found, right? This is called properties of cross product or vector product, right? Let us work out problems based on all the properties. See, A cross B is equal to I, J, K, A1, A2, A3, B1, B2, B3. Sine of angle is equal to magnitude of A cross B divided by magnitude A, magnitude B. Unit vector perpendicular to both A and B is vector A cross B divided by magnitude of A cross B. Area of triangle is equal to what? Half into magnitude of A cross B. What are A and B? A and B are the any two sides. Area of parallelogram, that is magnitude of A cross B. And the application is what? Moment. Moment is equal to F cross R, where R is equal to what? R is equal to AB, that is equal to OB minus OA. Make the list of formulas, then take the problems. First problem, find cross R vector product of 3i minus 2j plus k and 4i minus 3j minus k. I have taken two vectors. First vector is considered as A, second vector is considered as B. Let A is equal to, A is what? 3i minus 2j plus k. What is B? B is equal to 4i minus 3j minus k. What is formula to get A cross B? A cross B is always B in a determinant form, right? So A cross B is equal to I, J, K is first row. Second row is what? Constants in the vector A. Which are the constants? 3, minus 2 and 1. That is second row elements. 3, minus 2, 1. Third row is constants in the second vector. That is 4, minus 3, minus 1. 4, minus 3, minus 1. The coefficients of I, J, K should be taken along with their sign, right? No, this is the expansion of determinant. As we know, the expansion of determinant above the first row, you take alternatively plus, minus, plus. Okay. First element of the first row into a determinant of second order. That is obtained by deleting corresponding column and corresponding row. It is a principle of expansion of determinant. So that we have discussed in the first chapter itself. Okay. So if I leave the corresponding row and corresponding column, what are the remaining elements? Minus 2, 1, minus 3, minus 1. Next, what is sign? Formula sign. It is minus of. Which is second element in this first row? J. Leave the corresponding column and corresponding row of J. Leave this row and this column. The remaining elements are 3, 1, 4, minus 1. Plus, alternatively, you should take plus, minus, plus. Third element of the first row is what? K. Leave the corresponding elements of K and corresponding elements of the row. What are the other elements? 3, 3, minus 2, and 4, minus 3. This is the expansion of third order determinant. Now, simplify I into product of principal diagonal elements minus product of secondary diagonal elements, correct? What is product of these two elements? Minus into minus plus 2 into 1 is 2. Minus of 1 into minus 3. Product of secondary diagonal element is what? Minus into plus minus 1 into 3, 3. Minus of j into multiplication of these two elements. So it is important in every problem we have this A cross B, right? So therefore we should know the expansion of determinant, right? 3 into minus 1, minus 3, minus 4 into 1 is what? 4. Plus k into 3 into minus 3, it is minus 9. Formula minus multiplication of these two, 4 into minus 2, it is minus 8. Then I into 2 minus of minus plus 3. Minus j into minus 3 minus 4. When we have same sign, we should go for addition. Minus 3 minus 4, it is minus 7. We should take common sign and the number should be added. Plus k into minus 9. Remove this bracket. Minus into minus is plus 8. Finally, 2 plus 3 is what? 5. 5i minus into minus plus 7j minus 9 plus 8. So we will get minus 1. That minus 1 is multiplied with plus k. It is equal to minus k. This is the cross product or vector product of the given vector. See, we are always getting another vector. Take next problem. If A is equal to 2i minus j minus 3k and B is equal to I minus 5j plus 2k, find magnitude of A cross B. Find the magnitude of A cross B. So this problem is always be similar to this one. Here we got A and B. For that we found the A cross B. Here also for the given vectors you get first A cross B. Finally what you will get? You will get a such vector whose magnitude is to be found. Okay. A cross B is equal to I, J, K is first row. It is always unit matrix, unit vectors. Then which is B? A is what? 2i minus j minus 3k. What are the constants? 1, 2, minus 1, minus 3. Take them as second row elements. 2, minus 1, minus 3. B. Next vector is B, whose constants are what? 1, minus 5, and 2. Expand it. I explained the expansional procedure. Take the alternative plus minus plus first element of the first row into. Leave the corresponding column and corresponding row. What are the remaining element? Minus 1, minus 3, minus 5, 2. Minus of second element of first row, I into. Leave the column and row. 2, minus 3. I am leaving this column and this row. 2 minus 3, 1, 2. 1, 2. Plus of k into. Leave this column and row. The remaining elements are 2 minus 1, 1 minus 5. 2 minus 1, 1 minus 5. Then I into expansion of second order determinant. It is minus 1 into 2. It is minus 2. Formula minus multiplication of secondary diagonal elements. It is minus into minus plus 5 into 3, 15. Minus j into 2 2s are 4. Minus of 1 into minus 3 is minus 3. Plus k into 2 into minus 5, minus 10. Formula minus 1 into minus 1 is minus 1. I am taking separately. So I into minus 2 minus 15. It is minus 17. Minus j into minus into minus 4. Plus minus into minus plus 4 plus 3 is 7. Plus k into this is minus 1. Minus 1. So minus into minus plus 1. Minus 10 plus 1 is equal to minus 9. Finally, we get minus 17i minus 7j minus 9k. This is a cross B. We need to find out magnitude of A cross B. Okay. What is magnitude of A cross B? So it is a vector whose magnitude we need to find out. That's all. Minus 17 square, it is equal to 289. Correct? 7 square, it is 49. Plus 9 square, it is 81. So finally, you will get 9 plus 1, 10. 10 plus 9, 19. 1 carries. 8 plus 1, 9. 9 plus 4, 13. 13 plus 8, 21. 2 carries. 2 plus 2, it is 4. 419 is the magnitude of the vector A cross B. Next, let us take a problem on sine of angle between the vector. Find sine of angle between the vectors I plus 2j plus k and 3i minus 2j minus 3k. There are two vectors. You take them as A and B. The vector A is equal to what? I plus 2j plus k and B is equal to what? 3i minus 2j minus 3k. We need to calculate sine of angle, right? What is sine of angle? Sine of angle, that is theta. Sine theta is equal to, what is the formula for sine theta? It is magnitude of A cross B divided by magnitude A, magnitude B, right? Magnitude of A cross B divided by magnitude A, magnitude B. Calculate 1 by 1. So A cross B is equal to I, J, K. A vector constants are what? 1 to 1. 1 to 1. B vector constants are what? 3. Minus 2. Minus 3. Expand it. I into. Leave the column and row. 2, 1. Minus 3. Sorry. I am leaving this column and row. 2, 1. Minus 2. Minus 2. Minus 3. Minus of j into. Leave the column and row. 1, 1, 3, minus 3. Plus k into. Leave the column and row. What are remaining elements? 1, 2. 1, 2, 3, minus. Now expand it. I into 2 into minus 3, minus 6. Product of these two. Minus of 1 into minus 2, minus 2. I have taken separate. Minus of j into 1 into minus 3, minus 3. Minus 1 into 3 is 3. Plus k into 1 into minus 2, minus 2. Formula minus 3 into 2, it is 6. Finally, minus into minus is what? Plus 2. Minus 6 plus 2. Minus 6 plus 2 is equal to minus 4. Minus j into minus 3 minus 3 minus 6 plus k into minus 8. That is A cross B is equal to minus 4i minus into minus plus 6j plus into minus minus 8k. This is A cross B, right? We need magnitude of A cross B. Therefore, magnitude of A cross B is equal to, which is A cross B, minus 4i plus 6j minus 8k. Just take the numbers, square them and add it. Okay, minus 4 square is what? 16. Put plus 6 square is what? 36 plus minus 8. Minus 8 square is what? 64. This is equal to what? This is equal to 100, 116, 116, right? Next, we need magnitude of A, which is vector A. Vector A is equal to I plus 2j plus k. Coefficients are what? 1. 1 square is 1, plus 2 square is 4, plus 1 square is 1. That is equal to root 6. Magnitude of B, that is equal to root of, what is B? This is B, 3i minus 2j minus 3k. 3 square is what? 9, plus minus 2 square is 4, plus minus 3 square is 9. So 9 plus 9, 18, 18 plus 4, 22. Therefore, sine of angle sine theta is equal to magnitude of A cross B divided by magnitude A and magnitude B. That is equal to root of 116 divided by root of 6 into root of 22. So all are having root now. You take them in a root. According to Searle's root A by root B is what? Root of A by B. Like that 116 divided by 6 into 22. You can cancel it. 2 5s are 10, 2 8s are 16, 2 3s are. Again, we can cancel it 2. 2 2s are 4, 1 remains, 2 9s are 8. That is 11. That is equal to root of 29 divided by 11 into 3, 33. So if it further cancels, you cancel it. Otherwise, you take or you write same thing. This way, we need to find out A cross B, magnitude, magnitude A, magnitude B, and we need to substitute in the formula sine theta is equal to magnitude of A cross B by magnitude A, magnitude B. Next, find unit vector perpendicular to both A and B. A is equal to I minus j plus 3k and B is equal to 2i plus j plus k. Now mention the given vectors as A and B. What is unit vector perpendicular to both A and B? This is the formula. A cross B divided by magnitude of A cross B. First get A cross B. A cross B is equal to I, J, K. What are constants in vector A? 1, minus 1, 3. What are constants in the second vector? I coefficient, J coefficient, K coefficient. That is 2, 1, 1. Expand it. Expansion is what? I into. I am writing the second step. Leave these two, row and column. Remaining elements are these. Take their principal diagonal elements product. Minus 1, minus 1 into 3 is 3. Minus j into. Leave this column and row. Remaining elements are these 4. 1 into 1 is 1. Minus 2 into 3 is 6. Plus j into. Leave this column and row. 1 into 1 is 1. Minus 2 into minus 1 is minus 2. You can do directly also. That is I into minus 1 minus 3 minus 4 minus j into 1 into minus 6 minus 5 plus k into minus plus minus into minus plus 1 plus 2 is 3. that is equal to minus 4i minus into minus plus 5j plus 3k. This is what A cross B. What we need? We need its magnitude also, right? So magnitude of A cross B is equal to root of minus 4 square 16 plus 5 square 25 plus 3 square 9. That is equal to, it is 25 plus 16 plus 9. This is 50, correct? 9 plus 5, 14, 20. 2 carries 2 plus 2, 4 plus 1, 5. It can also be taken as root of 25 into 2 or root 25 into root 2, and this is equal to 5 root 2. Therefore, unit vector perpendicular to A and B is given by vector A cross B divided by magnitude of A cross B. So what is vector A cross B? It is minus 4i plus 5j plus 3k all divided by magnitude of A cross B is what? It is 5 root 2. We can also write root 50, that's enough. Otherwise, if it is simplifiable, you can simplify it. It makes no difference. Writing root 50 or 5 root 2. A force 3i minus 2j plus k is acting on a body at 1, 4, minus 2. Full stop. Find the moment. Find the moment of force. Find the moment of force about the point 2, 3, minus 1. So how to get moment of a force? So moment of a force is nothing but F cross R. What is F? It is the force acting on a body. What is R? It is distance between AB. What is given? You write given parameter force. F is equal to force 3i minus 2j plus k. Acting on a body, that is force is acting on a body at this point. Hence, force acting point is what? A of 1, 4, minus 2. Therefore, its position vector is what? OA is equal to I plus 4j minus 2k. Just include ijk. About point. Moment about point, which is about point B. See, find the moment of force about the point. So about the point is considered as B, that is 2, 3, minus 1. Therefore, whose position vector is what? OB. OB is equal to 2i plus 3j minus k. Get R. R is equal to what? A, B. That is equal to position vector of end point, that is B, minus position vector of initial point OB. Right, OB, what is OB? It is 2i plus 3j minus k. Put it in bracket. Minus of OA. What is OA? It is I plus 4j minus 2k. Remove the bracket. 2i plus 3j minus k, minus of second bracket. That means all the terms in the second bracket whose sign will change because we are multiplying with minus. So minus I minus into plus minus 4j minus into minus plus 2k. Finally, we get 2i minus I. You take the addition or subtraction according to the sign of common terms. I terms. 2i minus I is I plus 3j minus 4j. It is equal to minus j minus k plus 2k. It is equal to plus k. This is the vector R. Therefore, moment is equal to what? F cross R. Right? I, J, K. F, which is F, 3i minus 2j plus k. Take their constants, 3 minus 2, 1. R, which is R, I minus j minus plus k. What are coefficients of I, j, k? 1, minus 1, 1. Expand it. That is equal to I into. Leave the corresponding column of I, corresponding column of row of I. Remaining elements are these two. Minus 2 into 1 is minus 2. Minus 1 into minus 1 is minus 1. Otherwise, you can write directly plus 1. Minus of second element. Leave the corresponding column and corresponding row. The other elements are 3, 1, 1, 1. Therefore, expansion of that is 3 into 1, 3. Minus 1 into 1 is 1. Plus k into. Leave this column and row. 3 into minus 1, it is minus 3. Formula minus 2 into minus 1 is minus 2. That is equal to I into minus 2 plus 1. Minus into minus is plus 1. Minus 2 plus 1 is minus 1. Minus j into 3 minus 1, it is 2. Plus k into minus into minus plus minus 3 plus 2. Minus 3 plus 2 is minus 1. Finally, the moment of force is equal to minus I, minus 1 into I, minus 2 into j, 2j, plus into minus, minus k. This is moment of force when it is acting on a body at certain point, and we need to find out moment about the point, that is 2 comma minus 3 comma minus 1. Sometime they will ask you get the magnitude of moment of a force. Find the magnitude of moment of the force 3i plus j plus k about the point 2i minus 3j minus k when it is acting at 4i plus j plus 3k. Instead of giving points, sometimes they will be given their positional vectors. So in the last problem, they were given point. Here they have mentioned the points position vector, right? So what is force? Force is equal to, force is what? 3i plus j plus k. 3i plus j plus k. Which is acting point, force acting point. So force is acting at this. So that means this is OA. Force acting point. That is A. They have given OA itself. Therefore, OA is equal to 4i plus j plus 3k. So moment about point. Moment about point is what? B. They have given its position vector OB. About the point is this whose position vector 2i minus 3j minus k. First, get the r value. What is r? R is the distance between AB. According to position vector, AB is equal to OB minus OA. That is, OB is what? OB is 2i minus 3j minus k minus of OA. What is OA? 4i plus j plus 3k. That is equal to 2i minus 3j minus k minus 4i minus into plus minus j minus into plus minus 3k. Finally, you will get the r. Taking this simplification, 2i minus 4i is what? Minus 2i minus 3j minus j is nothing but minus 4j. Minus k minus 3k is also minus 4k. So we got our value. Now moment is equal to what? Moment is equal to F cross R. So what is F cross R? I, J, K. Take the F constants, coefficients of I, J, K in the vector F as the second row elements 3, 1, 1, 3, 1, 1. R is what? Minus 2, minus 4, minus 4. Minus 2, minus 4, minus 4. Expand it. So expansion is what? I into plus minus plus. Leave the corresponding column and corresponding row. 1 minus 4 is minus 4 minus of 1 minus 4 is minus 4. Minus j into. Leave the corresponding column and row. 3 into minus 4 is minus 12. Minus of minus 2 into 1 is minus 2. Plus k into. Leave the column and row. 3 into minus 4 minus 12. Minus of 1 into minus 2 is minus 2. That is equal to I into minus 4 minus into minus plus 4. It is 0. Minus j into minus into minus plus 2. Minus 12 plus 2 is minus 10. Plus k into minus into minus plus 2. Minus 12 plus 2 again minus 10. So finally 0i plus 10j minus 10k. This is moment of force. We need its magnitude. See, find the magnitude of moment of force. Therefore, magnitude of moment is equal to what? Magnitude of F cross R, which is equal to root of 0 square is 0, 10 square is 100, plus 10 square is 100. It is equal to root of 200. Or we want, you can further simplify it. 100 into 2, root 100 is 10, root 2. So many units. That is magnitude of moment of a force. Let's work out the problem on area of triangle. Find the area. Find the area of triangle having its sides given as 3i plus j minus k and 4i plus 2j minus k. Consider the vectors as the sides of triangle. This is side A and this is side B. What is area of triangle? Area of triangle is magnitude of A cross B into half. That is half of magnitude of A cross B. What is A and B? A and B are the two sides of a triangle. First get A cross B. That is I, J, K. A vector constants are what? 3, 1, minus 1. 3, 1, minus 1. B vector constants are what? 4, 2, minus 1. Expand it. That is equal to expansion of determinant. I into, leave this column and row. 1 into minus 1, minus 1. Minus 2 into minus 1, minus 2. Minus j into, minus j into. Leave this column and row. 3 into minus 1, minus 3. Minus 4 into minus 1 is minus 4. Plus k into. Leave this column and row. 3 2s are 6. Minus 4 into 1 is 4. I into minus plus 2. Minus 1 plus 2 is plus 1. Minus j into minus plus 4. Minus 3 plus 4 is again 1. Plus k into 6 minus 4 is 2. That is equal to 1i minus 1j plus 2k. Get the magnitude of A cross B. So magnitude of A cross B is equal to what? It is root of 1 square is 1 plus 4. It is equal to root 6. Therefore, area of triangle having the side AB is equal to area is equal to half into magnitude of A cross B. Thus substitute here half into what is magnitude of A cross B? It is root 6. That is root 6 divided by 2 square units. That is the area of triangle. Find the area of parallelogram having its adjacent side. Adjacent sides. I to I plus 2j minus k and 2i minus 5j plus 3k. These two sides are what? Adjacent sides. Take them as A and B. What is area of parallelogram? Formula. Area of parallelogram is only the magnitude of A cross B. Get A cross B. That is what? I, J, K. A constants are 2, 2, minus 1. B constants are 2, minus 5, 3. Expand it. I into. Taking alternative plus minus plus over the first row. They are the standard signs. I into. Leave the column and row. 2 3s are 6. Minus 1 into minus 5. That is equal to plus 5. Minus j into. Leave this column and row. Again 3 2s are 6. Minus 2 into minus 1 is minus 2. Plus k into. Leave this column and row. Minus 10. 2 2s are 4. That is equal to I into 6 minus 5 1 minus j into minus into minus plus 6 plus 2 8 plus k into it is minus into minus is minus 14. It is I minus 8j minus 14k. This is A cross B. Therefore, magnitude of A cross B is equal to root of 1 square is 1 plus minus 8 square. It is 64. 14 square. 14 into 14. 4 4 the 16. 1 4 1 the 4. 56. 1 4 the 1 1 the that is equal to 6. 196, which is equal to 196 plus 4, 200, 261. So therefore, area of parallelogram is equal to root of 261 square units. So in all the problems, we have A cross B. So if you know the expansion of determinant, it will be very easy to work out any problem. Only that you need to remember a particular formula, right? So today's class, we discussed the multiplication of vector, in which we did a cross product or vector product. So you work out more number of problems on this cross product. Okay. With this, I conclude my today's class. Do you have any queries? Please ask us.